Hello, my name is Jimmy Costello from the NX product marketing team. Today we're going to be looking at how we can model a part for the first time. Siemens NX is a powerful computer-aided design, computer-aided manufacturing, and computer-aided engineering software suite. It provides a comprehensive, integrated platform for product development, from conceptual design to manufacturing. NX offers advanced 3D modeling tools, simulation capabilities, and seamless data management, allowing engineers and designers to create, validate, and optimize their products efficiently. In this video, we are going to create the gearbox cover for this gear motor assembly. We will cover the basics of creating a new file, creating our first sketches, and taking these sketches to real-life designs. Additionally, we will also explore what resources are available to help you improve and refine your design capabilities moving forward. Let's go ahead and get started. To begin, the first step in modeling a part is to open a new file. We can do this by selecting File and then New. When this is done, a new window will open, offering a variety of template parts to choose from. The categories at the top of the screen represent the application we will be working in. NX offers numerous design capabilities, but for today, we will just work within the model application. Even within modeling, there are a variety of templates to choose from. Each of these templates will provide different design capabilities and interfaces optimized for your workflows. For our purposes today, we are going to stick with this first model option. One other thing to notice when creating a new part is the Units drop-down box. This is where we can select the measurement system we will use to define our new design. With that finished, the final step in creating a new part is to select a name and a folder to save to. Staying organized is a very crucial aspect of design efficiency, so use a system that makes sense for your workflows. It's important to save early and often. This ensures that all your design work will be protected and each revision that is made is available downstream. Now that we have opened a new file, let's familiarize ourselves with the screen layout of NX. At the top of the screen, the title bar shows what application we are working in. Underneath of this, we have a number of tabs to assist with the design process. The most commonly used commands can be found within the Home tab, but many of the more complex design actions will require the use of these other tabs. Additionally, if at any time we would like to change the application we are working within, we can select the Application tab and then the new application we would like to switch to. Another key aspect of the layout of NX is the resource bar, which is pinned to the left-hand side of our screen. Once again, we have a variety of tabs to assist the design process. The most important tab when we're getting started is the Part Navigator. The Part Navigator organizes all the features that are produced throughout the design process. If at any point in time you need to go back and make changes to a previous feature, this is the place to look. One other key component of the layout of NX is the search bar in the upper right-hand corner. This is an excellent resource to quickly find and access various tools, commands, and features within the software. Now that we have looked at the basics of the screen layout, we can go ahead and begin to model our part. The first step in creating a new part is to begin with a sketch. The sketch command can be found under the construction group within the Home tab. Upon selecting this command, we are prompted to select the plane our sketch will be made on. When we're starting off, this isn't very important, but this step does become significant once other features have been created. There are a few basic things to keep in mind when creating new sketches. The two biggest items are to keep sketches simple and make sure they are fully defined. As we begin to produce our sketch, we can track our progress inside of the Sketch Navigator. This can be found within the resource bar on the left side of the screen. The Sketch Navigator is a centralized and intuitive interface for managing sketches. Each line and curve that is produced will be organized here, so we can track new changes as they are made. One of the most important steps in creating a sketch is to fully define each curve and line. The Sketch Navigator informs us when this is done. In the Curves tab, the status column shows when each arc and line is fully defined, with the sketch row at the top of the window, displaying the overall status of the entire sketch. A black circle indicates the sketch is fully defined, while a white open circle shows there are still dimensions that must be clarified. As we progress through this first sketch, we can see that once a curve or line is dimensioned, it changes colors in the display window. Before finishing our sketch, we need to remove the section of the rectangle that obstructs the connection of the latest lines to the body of the sketch. A quick tool to assist in this is the trim command, found under the edit group. If we click and drag across the existing line, NX will automatically update the shape of the sketch. With our first sketch finished, we can begin to take our 2D design to a real 3D product. The most common way to do this is with the extrude command. The extrude command in CAD is used to create a 3D shape by extending a 2D sketch along a straight path, usually perpendicular to the sketch. We are prompted to select a distance for the sketch to extend to, and now we have the start of our 3D design. Next, we can begin to create the second part of the gearbox. This time, when we create a new sketch, we're going to select the face of our new body for the sketch plane. Instead of using lines and shapes, we will now leverage the Profile tool. With the Profile tool, we can define the outline with a series of connected lines in a string. The end of the last curve becomes the beginning of the next curve. The value of this tool lies in its flexibility and efficiency. This workflow saves time and makes it easier to experiment with different design ideas. Once again, as we finish this sketch, it's important to fully define our curves. When we want to define an angle, we must select two adjacent line segments consecutively. This serves as a great alternative to length dimensioning, and in certain scenarios, provides a more efficient method of design. Once again, as our sketch is fully defined, we can finish and move on to the 3D side of design. We will use the extrude command here as well, but this time we will use an offset to center the new 3D feature along our initial body. Our part is finally starting to share some resemblance to the initial gearbox cover, but there are still a few more crucial steps to finish up. The first tweak we are going to make is to put a chamfer along the top of our 3D body. This will help to mimic the draft along the cover currently used on the gearbox. Chamfers can be useful in improving ergonomics and part manufacturability. The next step in our design is adding in our holes along the edges. To do this, we're going to start with a simple singular hole and then practice using the pattern feature and mirror feature commands. There are a few methods we could implement to simplify this step to require only one pattern, but using both tools will be good practice and experience today. To begin, the hole command can be found on the Home tab in the Base group. To place our hole, we are going to use the Sketch Point tool that is built into the hole command. This will allow us to properly place our hole at an appropriate distance from the sides of our part. After we have properly centered our point, we can finish our sketch and the hole dialog window will reopen. Now, all that is left is to set our hole diameter and we can finish our first hole. One quick and easy way to replicate this without extra unnecessary steps is the pattern feature tool. The pattern feature command is a powerful tool that allows you to quickly create multiple copies of a selected set of features or geometry. Pattern feature can create linear, circular, or rectangular patterns. In this scenario, we're going to use a linear pattern to replicate our hole along the vertical axis of our 3D body. In addition to defining the pattern, we can choose from various spacing options. This time, we'll use count and span, which allows us to specify how many times the feature will appear and the distance it will span. Once we've set our values, we can select OK, and we now have 4 out of the 8 holes. The last tool that we will use to finish off our whole design is the Mirror Feature command. The Mirror Feature tool creates a new set of features that are a reflected copy of the original selected features. This is done by defining a mirror plane, which can be an existing plane, a planar face, or a user-defined plane. Here, we will create a new plane that is offset to split our part in half. This will ensure that our existing hole features are identically spaced along the other side of our gearbox cover. Reviewing our part, we are now nearly finished reproducing the initial gearbox cover. To round off our corners, like the initial design, we can leverage the Edge Blend command. The Edge Blend tool is used to create smooth, rounded transitions between intersecting surfaces or edges. This can help to improve the aesthetic appearance of a part, as well as enhance its structural integrity and manufacturability. I'm going to select all the edges of our part using the Body Edges Smart Selection tool, and we can quickly finish up our model. With our part now shaped and designed, we can next turn towards making it a presentable end product. The first step in doing this is to navigate over to the Display tab at the top of the screen. Inside of here, we have two primary options. We can assign visual materials or edit object display. Let's take a look at what each option has to offer. Choosing to edit the object display allows us to modify the visual representation and display properties of our part within the modeling environment. We can control object visibility, color, and transparency, which enhances visualization without changing the actual geometry. Additionally, the Edit Object Display capability is also often used to highlight specific parts and assemblies, distinguish between different components, and improve visual clarity between design iterations. On the flip side of things, assigning visual materials is important if you want to take your design a step further. First off, assigning visual materials is important for realistic visualization. Rather than just a stock color that can be chosen in the Edit Object Display, this ensures accurate material representation. Additionally, assigning materials is important for further simulation and analysis. When applying a new material, key qualities such as density, elastic properties, and thermal properties are included. This makes future testing with tools like Performance Predictor and Sustainability Impact Analysis more accurate and precise. Before we wrap up today, I want to end off by providing a few places to explore as you continue to refine your NX design skills. The first and most immediate option to investigate is the Discovery Center. This is a great place to look around when you're just getting started for the day, to learn more about NX. Inside of here, there's also a section dedicated for additional getting started materials. This can be found along the top. Clicking on any of these links will open a new window in your browser with additional tutorials and resources to further your learning experience. The best way to go about improving your design capabilities is to continue practice with new design challenges. Using these tutorials and resources provides a bit of guidance, but any modeling in NX will help. In conclusion, in this video, we've reviewed the essential steps for modeling a part for the first time. We started off by looking at how to create a new part file to begin our work. After that, we investigated the basic layout of NX to get a better understanding of where important tools and commands could be found. Next, we began to sketch out the basic shape of our new part, focusing on fully defining our new sketches. From there, we were able to use the extrude tool to produce a 3D product. After that, we refined our end product using the hole command, chamfers, and edge blends. Switching gears, we next focused on the display of our new model. And finally, we wrapped things up by exploring the next steps to polish and improve our CAD skills moving forward. I would like to thank you for your time and attention.